Hello, geometry. All right, we're going to continue our talk about trig ratios and using trig functions to find parts of a triangle. Notice while I'm taking notes, I have my little Desmos calculator here because I know we're going to be using it. Today, we're actually going to be talking about the application of trigonometry and trig functions by using angles of elevation and depression. So let's define these terms really quickly because sometimes these get a little bit tricky in deciding which one is what. So angle of elevation is it's a moving up of line of sight. Horizontal line of sight. And you'll see this when we do our clinometer activity. So think about if you're looking right straight, that's a horizontal line of sight. So angle of elevation would be an opening up. So you're gonna be looking up. So thinking about that, looking up, right? So here's an example of an angle of elevation, and here's angle of depression is just a moving down. So think of moving down of horizontal line of sight. So think about looking down, right? If you're looking down, you have an angle of depression. So examples here, looking up would be like looking up at a tall building or at a bird. That would be angle of elevation. Angle of depression is like if you're in an airplane and you're looking down at the cars on the road, that's angle of depression. Or if you're in a tall building and you're looking down, or even if you're in a second story of something and you're looking down, that's still angle of depression, okay? So let's classify each angle of elevation or depression. So let's look at his line of sight. His line of sight is here, right? Because he's on the ground and he's looking up. So if he's looking up, then he's going to be having an angle of elevation. All right, now he's on a cliff, right? Here's his horizontal line of sight, and he's looking down at this sailboat. So if he's looking down, it's an angle of depression. All right, so let's try this. Angle 3, he's looking, here's his horizontal line of sight, and he's looking down. So that's going to be depression. And then for this guy on the ground, he's looking, there's his horizontal line of sight, right? So he's looking up, so he's having an angle of elevation. So this is important to know when we're thinking about trig functions, right? Because we're gonna have some word problems that describe some of these things. I do have it back, okay. So let's try letter D. This is thinking about the lighthouse. This isn't actually a person, but that's okay. Here's the horizontal line of sight. So angle 1 up at the bird would be elevation. And then angle 3, still thinking about the lighthouse, is looking down, so it's depression, right? And then here's our bird, right? If the bird were to look back at the lighthouse, there's his line of sight, horizontal. It's down here for 2, so depression. And then angle 4, think about line of sight for the sailboat. He's going to be looking up at the lighthouse, so that's elevation there for 4. Just a quick review on that. Sometimes it gets a little bit tricky. So let's look at a couple of examples here when we're actually going to be using math to find what the height of things are. So these are like what we're going to be doing with our clinometers. When the angle of elevation to the sun is 52 degrees, so angle of elevation here, a tree casts a shadow that is 9 meters long. So here it's kind of hard to see, but that's 9 meters. What is the height of the tree rounded to the nearest 1/10 of a meter? So we're going to follow our steps here, right? Remember, we're going to label, then we're going to write our equation, and we're going to solve, and then we're going to plug back in. So things we've been doing already, 1, 2, 3, 4. So we're going to label because I want to know what the height of the tree is. Well, the height is here, right? So I'm going to call this X. So let's think about this in triangle form because sometimes when I have it with a picture, it gets a little bit confusing. Here's my right angle. This is 9. This is X. and this is 52. So this looks familiar, right? All right, so we've labeled, and now we're going to decide which equation to use. Are we going to use SO, CA, or TOA, right? Still coming in with our trig functions there. So because I always, start at my angle, right? X is across the triangle, so it's opposite. 9 is next door to 52, so it's adjacent. So what are we going to use? O and A. O, A. Oh, there it is. We're going to use TOA here, right? So we're going to say tangent of our angle 52 equals opposite value X divided by adjacent value 9. Same way we've been solving it. Put it over 1, cross multiply, right? So we have X equals 9 times the tangent of 52. Now I'm going to grab out my calculator. Good thing I had it already. And we're going to say 9 times the tangent of 52, and we get 11.5. So we need the nearest tenth of a meter, just checking there. So if it's 11.51 rounds, it stays to 11.5. And meters, let's make sure to get our units in there. We're just thinking, does that make sense for a tree to be 11.5 meters? Each meter is about 3 feet, so does it make sense for a tree to be 33 feet tall? Sure it does. That sounds pretty good. All right, so let's look at example 3 here. A person snorkeling sees a turtle on the ocean floor at an angle of depression here. Oh, this one's going to be tricky, all right, of 38. She is 14 feet above the ocean floor. How far is the person from the turtle rounded to the nearest foot? So this one's a little bit tricky because we have to add, right? And we have to add a step. So here's my triangle here, but what I'm noticing is that 38 is not in the triangle. So I need to figure out what this angle is. Well, if this is 38 and all together we know it's a right angle, I'm going to use my calculator and figure out what that missing angle is there. Oops. 52. All right, oh, that's a repeat, isn't it? So that's really 52 degrees. We need the angle to be actually inside the triangle, and we don't have it in there. So we're going to do our same thing here. We're going to label. This is 52 degrees, this is X, and this is 14, right? Here's my right angle. So I'm going to label, right? I need to figure out what each one is. 14 is right next door, so it's adjacent. Okay, and X is across from my right angle, so it's hypotenuse. Now I'm going to decide which equation to use. Am I going to use SO, CA, or TOA? Well, I have adjacent and hypotenuse, A and H. We're going to use cosine. So our equation is going to look like this. Cosine, always of our angle, 52, equals adjacent 14 divided by hypotenuse X. Place it over 1. Cross multiply here. So we have an X times cosine of 52. We've done these before. You're good at them. And then we're going to divide by that cosine of 52 because it wasn't quite solved for. And we were rounding to the nearest foot here. Keep that in mind. So 14 divided by cosine of 52. We get 22.7. Nearest foot, looking at that 7, it's going to round it up to a 23. So 23 feet. So that means that the turtle was 23 feet away from the girl, or the girl was 23 feet away from the turtle. Either one of those. I think turtles can swim pretty fast, so I'm sure that didn't stay 23 feet for long. All right, example 4 and 5, we're going to do in class together, but this kind of gives you a good idea of how we're using the clinometer to find angles of elevation and depression. We're specifically going to be looking at ideas like this here that we'll share today in class.